Hi everyone, my name is Marius and today we'll be doing the second video of the ABCs of securing the branch edge with a router. Okay, as you can see this is video 2. If you have not seen video 1, perhaps it's a good idea just to scroll over video 1 because today I'll be referring back to video 1 quite a bit. Okay, in video 1 remember we spoke a little bit about basically either using a packet filter type firewall, which is access control list, or you could use ASPF, which is more an adaptive security algorithm, right? Saying that whenever a packet goes out, I'm expecting a specific packet to come back in again. Like in TCP/3 or Handshake, if I send one packet out, I'm expecting a specific packet from a specific place to come back in again, and I'll only open a pinhole for that one specific packet and remove it from the access list, right? And of course, that's what I want to focus on today with the ASPF. Yeah. So for today, it's all about configuration. Yeah, okay, so effectively what we have is, and I just want to draw a very quick network for you. All right, so right now let's go blue. That's an interesting color. What I have is we've got the World Wide Web. This is actual case right now. It's connected to my small office, home office router, Soho router. All right, typically I run this as a firewall, but for this demonstration purposes I've actually disabled this. Okay, so you can see the actual hits and so forth. This is my inside network. Right, bunch of devices. I've also got an AP over there, yeah, and I've got a bunch of devices connecting to that again. And what I've done right now is I've actually put another router in here. That's a 2K router from HPE. And effectively what I've done is I've created an inside network, and I've also created this laptop that I'm presenting from right now. Laptop, let's call it my save device that I want to save. All right, save. Make sure that everything is good. I've put on the inside of this network. And let's say what I want to do right now is effectively make sure that traffic cannot get to this laptop from the outside in. So in this network right now, we've got two divisions. From a security point of view, that's important, right? We've got the inside network and we've got the outside network. Yep. So remembering with ASPF, what I'm going to do is I'm going to apply a policy, right? Outbound on my outside interface. That over there is gigabit 0/0. I'm going to apply it outbound. But what we also don't want to do is we don't want to allow any traffic to come inbound into this network. So for now, I'm actually going to run access controllers 3000, right? And I'm going to deny IP, and I'm going to apply it inbound, right, on the same interface. So effectively no traffic by itself can come through this network. All right, so that's what I want to do. Then I'm going to take both those two. So I'm going to create the access list, create the policy, and then I'm going to bind those two to the interface gigabit 0/0. And those are the 3 steps required. Okay, in the actual ASPF policy, I want to detect TCP and UDP for now. That's it. Okay, and the way I'll prove it is I'll actually just show you basically, I'll just hit an access, basically a website from this laptop, and show you what the sessions that's being set up and so forth. We'll also run a debug very quickly as well. Okay, so for now, that's basically how it's set up. I've got an IP address infrastructure here. Let me just put it in here for you. This is 10.1.2.0. This is .2.1. And this is 10.1.1.0.1. And this is .254 because I have a DHCP running over here, assigning IP addresses from this router. Right, and then on this port there, I'll be running NAT. Right, so it does a one-to-many NAT. Basically, all of these devices are NATed to one public IP address with ports and so forth. Right, so strictly spoken, that should then be a PAT. Yeah, everybody with me so far? Good. Okay, so that's basically the setup on this case. I am not going to go to this router at all because I've got some private information on there and I don't want to show it all over the world. Okay, so if you'll excuse me, I'm going to run there. More importantly, what I've also set up, and there's a very good reason, is I've actually set up ASPF over here. Okay, you'll see why I've done that. Good, let's get on to the actual firewall itself. I hope you can see all of this. All right, let me just make it a bit smaller, otherwise it just becomes uncontrollable. And let's just drag it out a bit. Yeah. Okay, so that's the firewall for now. If you do a display ASPF policy at the moment, let's say 1, display ASPF sessions. Okay, I have nothing set up at the moment. If you do a display access controllers all. There's no access list set up at the moment. If you display interface brief, there should be 2 IP addresses in there. That's a 10.1.1.254 and a 10.1.2.1. Display OSPF. Display OSPF. Yeah, I'm not going to show my peer, otherwise you can actually pick up on the other side what my public IP address would be. Okay, from my OSPF device. So for now, if you'll excuse me, I'm a little paranoid here for security. Not going to show that to you. But effectively, I do have display OSPF routing table. Yeah, I do see some routes coming through. Good. So effectively, as we see this right now, let's see. Let's set it up. So I said there's 3 things you need to do. You have to create an ASPF policy. Let's, before we do that, just switch on debug. I like to run debug here. Okay, debug ASPF all. Okay, so that's now been set up. Okay, so let's just make sure we're going to get it. Terminal monitor and terminal debug. Okay, done. System. Then I say ASPF policy 1. That's it. Remember the previous versions of the actual operating system, you needed to specify detect TCP, detect UDP. Right now, that's automatically from the latest release, that is already supported. So I don't have to do anything else. I'm just setting up a policy. I quit out of it. I say access control list 3000. Sorry, before it was that advanced 3000 rule. Give yourself some space to play with. 10 deny IP at this point. I'll get it right. Deny IP. Display this. Okay, so at the moment I've got to deny IP. Now I go to interface gigabit 0/0. Display this. You'll see that nothing is bound to it, just an IP address. And I say ASPF apply policy 1 outbound. That's step 3 we're busy with. And I say packet filter 3000 inbound. But look at this now at the moment. It's not doing anything. I've already applied an ASPF policy outbound. I've already set up the ASPF policy, everything else. If we do a display ASPF sessions, all right, there's some sessions at the moment that's already starting to start up. So you'll see that sessions are created. Okay, but what I want to show you is as soon as you apply the actual access list inbound, it'll start to associate that with the policy because it's on the same interface, and you'll actually see the deny statements coming through as it's actually blocking traffic from the outbound in. Right, so packet filter 3000 inbound. Yep, there it is. Okay, so basically I've now set up an access list inbound, and there's already packets that's trying to come from the outside in, and this machine is now actually blocking that. Right, and it's actually picking it up as an ASPF dropped. Okay, it's dropped by a packet filter and so forth. So as we actually apply or we create new sessions inside out, it'll automatically apply those to the access list. We'll use the access list to actually build those inbound sessions for us that's allowed to come in. Right, but something that's going to happen hopefully very soon that you'll see is that my OSPF has just changed down. Do you see that? Why? Because the access list does not distinguish. It's saying at this point, deny IP. Anything in IP is denied. Undo. Let's sorry about that. Undo, debug, all. Okay, just switched it off. So if you do a display OSPF, all right, routing, all right, you'll see that it will basically now say everything is dead. Can't find anything, okay, because my OSPF is down. Display OSPF, peer. I don't have a peer anymore because in the actual access list it's been denied. Okay, so if I go to system, be very careful of this. If you need any outside in traffic, you need to enable that. But since this is not internet facing, it's actually router facing, I have to now take care of that. Right, if you're going to be running something like DHCP, you have to enable DHCP inbound packets. Otherwise, you will not see traffic. Okay, so let's quickly go there. Access control list 3 advanced. I keep on doing that. 3000. Okay, so let's make it a rule 5 permit OSPF. Okay, so all I've done now is I've just basically said to it it's allowed to actually allow packets from OSPF to be inbound. Display access control list all. And what you'll see, it's just come up again. Okay, so there's my 3 matches from the ASPF. Done. So my ASPF is back and running again. Okay, so if I do a display ASPF session, okay, I do have 2 sessions right now. It's coming from 10.1.2 going to 192.168.0.2. Right, there's some destination port there for protocol TCP. Okay, I'm not exactly sure what that is, and you'll see some ASPF going on there as well. Okay, so if I go and open up, let's say just google.com for now. There it is, that's come up, that's running at the moment. So I haven't done anything, and you actually go back to there and you say display ASPF session. What you'll find is there are some sessions to 172.217.17.106, yeah? And there's a session to 172.117.132, port 443. And as you can see, we have quite a couple of sessions opened right now. That's all the sessions required to open Google on different ports. Right, you can still see I'm opening all the different sessions. That's one HTTP session to Google. I haven't opened anything else. It's 44 sessions just to get this page going. That. Okay, so for the guys who wants to do this in access control list, you know, you can really try that. That's virtually impossible today. Okay, and that's why we need an adaptive algorithm. All right, that can actually adapt to this environment. That will open pinholes for the information coming back from those specific ports. Okay, and you'll see that there was some DNS resolution here as well. Okay, that was a DNS resolution to start off with. 262.172, that's actually my DNS address. Okay, that's my DNS and DNS. So the ones should be UDP, there they are, UDP, there they are, you see that. Okay, so from that perspective, these are all the sessions open up, most probably because I'm actually logged in at the moment. Right, with Google. And you'll see those are 443 connections. Interesting stuff, yeah? Okay, so if I were to go to something else, like I said, I'm a bit of a beer fanatic, hard to brew, if you ever want to know that. I'm not promoting anything like beer, that wouldn't be good. Alright, but basically, if you now go back and you did the sessions again, just to get this very simple site and connection up and running. Okay, so this is almost impossible to do in access list, right? There's some sessions now because I've actually overwritten the other session, yeah? So now I have 41 sessions for this specific site, so that's 39 odd sessions, whatever the case may be. And you'll see some DNS as well happening in the background as well. And of course with ASPF. Okay, so that's just a good idea. If I did the following, open a new tab, I think you know where I'm going with this, alright? And display ASPF session, it's actually for my own curiosity as well. Now I have 2 sessions open. Sorry for the dead time or dead space. Alright, there's sessions, 37 sessions now, whatever the case may be. So it keeps on changing the whole time. So quite an interesting setup, yeah. And to be as dynamic as this is very difficult in real life. And what you want to do is I want to show you the sessions keeps on changing. And what's good about that is the fact that the ASPF keeps on shutting sessions down as we change different sites and so forth. It keeps on shutting things down and starting things up again. It's very dynamic based on port numbers. So that's quite cool to work with. Right, in the meantime, it's blocking all the traffic from the outside in, except for ASPF traffic. Guys, just to go and set it up again, just to show you, effectively what we've done is, we set up an ASPF policy, right, one, and that was it, display this, alright. The one thing I would quickly want to try and do is, I think I still have it open, no I don't, give me 1 second, I'm just going to open a command center here, okay, and draw that in and basically do a ping 10.1.1.1. Alright, and effectively as you can see by default, you know, I can ping through the actual router itself. We can also go and disable certain things, you know, and make sure. So I can ping it, but you'll see if I try and ping from the outside in, I can't ping from the outside in, right, because it's the outside in traffic, unless I actually allow ICMP traffic to go through. This is not total security, please understand that. What we are saying, that's just another level of security. We do try and stop people coming from the outside in. That was the whole idea behind this. Right, so I hope you found this to be useful. Like I said, there was 3 steps to set this up. It's first of all to set up the actual ASPF policy. Right, by default, the new releases will automatically detect TCP and UDP. If I want to do specific type of traffic, like FTP and so forth, I would just say detect FTP. And you've seen that in video 1. But if I can also quickly show you that, and I say detect and question mark, these are protocols and applications that needs a little bit more data, multiple, right, streams of traffic and so forth, things like FTP, DNS and so forth. I can actually do that as well. Right, for now, as I explained in video 1, we don't need that for the basic connectivity, but it's up to you to basically use it. Access control list for an inbound, deny IP, remembering that you want to permit whatever outside in traffic you need to allow. You need to allow first and then deny IP. Bind both of those to the actual interface, that is the WAN facing interface, and that's it. It's done. Okay, from a head point of view, I'm using a 1K 1003 router, basic connectivity on the inside out. I get 180 meg throughput before switching on security, and after switching on security, of course, when you do the actual upload of traffic and download of traffic, I see a hit of less than 5% on CPU. Okay, I still get about 165, 170 meg throughput on all types of traffic, YouTube and so forth. So I'm quite happy with that at the moment. Alright, so that's the end of my video. Hope you enjoyed it, and in my next video I'll take this to the next level and we'll basically set up some security zones and so forth. Okay, I just want to thank you for your time, and hopefully you use this. And by the way, remembering that this is based on the actual current license. So if you've bought this from HPE and you want to switch it on, or HPE, you're more than welcome to switch it on. There's no licensing cost associated with this, which is pretty cool. So you can give it a go, give it a try, see what happens. Thanks guys, appreciate your time, bye bye.